Thanks, Ken. By the way, I do a lot of lazy inversions myself. I'm not saying that I'm any different.
That's the pointer?
Okay. So when Ken first told me about the workshop, I thought actually it was supposed to be about deep exploration, especially because he was talking about bringing Dan Woods in, and Dan's talk was about mining at 1 and 2 kilometers. And then I realized it was called undercover exploration. But, and they're not necessarily the same thing, as some people have pointed out this morning. So I'm going to stick with the deep part, but I had to ask, what is undercover? And actually, I'm going to put this up at the end, and I don't plan to fill up my my time slot, so at least have maybe hopefully 10 minutes for people to give their own opinions. What is undercover, and what was undercover 20 years ago still undercover today? Not because of some hyperactive erosion, but through better understanding and technologies, and especially geochemical technologies. I'm really happy that we've got a slot with James Coverley, because I'm a geophysicist. I always have been trained, but I'm a huge fan of geochemistry, and in fact, a lot of the problems that we talk about, I believe, will be solved by the geophysicist and the geochemist in equal proportion in these areas where the poor geologist wanders around and can't see anything on the ground. So undercover is not a lack of outcrop. This is just my view. So, for example, so deeply weathered in situ regolith, all right, is usually amenable to some amazing soil geochemistry results, and I hope we're going to see some of those just after lunch. And it also, it doesn't have to be, for example, a leached regolith, right? So people for decades maybe explored for copper by sampling for copper and found nothing. But if they sampled for other elements, they would have found something. And I've seen some amazing examples in Chile where there's practically no copper anomaly, but if you sampled for moly, you've got a bullseye. Another example closer to where First Quantum works is in the Kimono Deposit in the DRC, and one that Barry is much more of an expert on. But this lay hidden for a long time, partly because it was outside the traditional Congolese copper belt stratigraphy, so there's a really good conceptual story there. But the other reason is that it has an unusually pyritic hanging wall, pyritic sandstone. And there was a lot of acid leaching of the copper, so there's no, traditionally in the copper belt you could walk up and you could see malachite on the surface, and that was the start of the exploration. So there's nothing to see on the surface there as far as I understand, and even the soil geochemical results are nothing to write home about in copper, but it is a little more relatively enriched in zinc and lead. So you're looking for copper, but you should sample for zinc and lead. So undercover is transported overburden that either masks or displaces the surface geochemical expression of mineralization. So wind-blown sand, transported gravel, and probably one of the hardest of all is younger surface volcanic flows. So what are the reasons for looking deep? So I'm not a Richard Shoddy or Graham Asco, but so this is just the kind of amateur take on it. But the junior purpose, and because I'm putting this up because there's a reason that First Quantum looks deep. So the junior purpose is to get an intersection, right? And it really doesn't matter if it's going to be economic. It has to grab the attention of people. And 5 years ago, 50 meters at 0.8% copper would get you a share price spike, and people wouldn't even bother to read down the press release to find out that it started at 800 meters depth. And to get the interest of the top of in town, who have the dollars and often will probably mine it. The kind of operations that Dan Wood was talking about, especially because historically, or for a long time, a lot of the majors have been much more concerned with tons in production and actual profit. And it was interesting that Lee Sampson stood up a couple of days ago and told us that Barrick, the world's largest gold miner, who have always wanted to have the most ounces and the most production, have decided that they actually want to turn a profit these days as well. So they're changing their tack. So a third reason, the research hole, kind of and this is actually, First Quantum does quite a bit of this, and I have to admit that actually First Quantum doesn't believe in deep exploration. We don't think we we have to go looking deep, but we do drill deep sometimes, and that's just for geological understanding. So it's it's wasted in the sense of finding mineralization, but the eventual outcome is to help us search better near the surface. So do we really need to look deep? Well, so as an industry, maybe is probably yes as an industry. If you look at the kind of shortfalls that Dan was talking about in the decades to come, and Graham pointed out in the copper, and if you're going to mine porphyries, eventually those volumes are going to have to be mining at 1 and 2 kilometers. As an individual company, no, not at all. You don't have to look deep. But do you have to look undercover? Yes, or undercover or under hidden. Something hidden. Okay, so on to the actual examples. So just 2 examples. One of them is a nickel sulfide deposit and target up in northern Finland. And that was deep drilling based on some seismic data and some concepts. And the other example is a sediment-hosted copper deposit in Zambia, where the deep drilling is on concept alone. And we're actually, it's quite interesting, we don't actually want to find mineralization. We'd be disappointed if we did, and I'll show you why later. So in northern Finland, it's a mafic, ultramafic intrusion. It's been intruded, it's probably come in via the southwest here into country rock, which is, it's a big syncline of interlayered metavolcanics and metasediments, which is the country rock. And this is a very deep part of the intrusion, and this is a very shallow interlayered. So this is all basically olivine peroxenite, and this is layers of gabbro, basalt, then shales, and it's quite complicated. But we figured it came in from here and kind of filled up maybe a big depression that was created by a fold interference pattern. That's the way we like to talk about it today. It'll change tomorrow. It's not a very exciting deposit. These are grades that are, 15 times normal mafic abundance of copper, so we don't want to find another one of these, but we've got this one. And we've got seismic. So these are existing 2D seismic lines that were run by the Finnish government. And there's a box, hopefully you can see better than I can, of a 3D seismic survey that we ran about 3 years ago. So where's the good stuff? Because this is not the good stuff, right? So the whole exploration mandate was, we've got this deposit, it's going to be mined, it's going to hopefully make a little bit of money, but if we can find high-grade parts to this, then that's just extra cream on top. So the 3D seismic survey was actually shot as more of a geotechnical survey. We wanted to provide to the mining engineers a 3D cube of structure ahead of the open pit, commencement of the open pit and the mine planning. But obviously we're using it for exploration purposes as well. And so the only part I'm going to talk about here is how we've used it to define the base of the intrusion. And originally that's because we wanted to use this to constrain our search for this kind of contact type mineralization, or maybe look for feeder zones and stuff. And that's a bit of an outdated model now, I think, and we've kind of gone cold on the concept of finding the high grade in this existing resource area. Just briefly, because nickel sulfides or massive sulfides occur in really dynamic magma environments, and this is a very quietly layered, subtly layered, but quietly layered area of, magmatic layering, and it's anything but dynamic. So it's probably not going to be in this area. But nonetheless, at the time we shot the seismic, we were still thinking that. So together with drill pierce points and the 2D and 3D seismic, we have this base of the intrusion. And then we started looking at this thing, which we thought, well, we don't know where this came from and why it's sitting there. And so we're looking for all kinds of excuses to go chasing where this came from. This is another shot of it, this big kind of blank area, seismically transparent. Could that be another extension of the intrusion? And shall we look there? So we did, and we put down a 1.7 kilometer deep drill hole. So in this case, we did want to find mineralization. Unfortunately, we didn't. And but it's given us a lot to think about. So this is the main intrusion. Like it's like a big deep bowl here, and here towards the southwest, you've got the interlayered gabbros and shales and basalts and all kinds of stuff, more complicated than this simplified cross section. And so we collared here in olivine peroxenite, and we drilled, and instead of going through all this other stuff and eventually hitting probably more olivine peroxenite, we went through solid olivine peroxenite all the way down, and we never got out the bottom. So we have a lot to think about. Even more surprisingly, because here's the drill hole, collared here, here's the seismic line, and we drilled this way. This is the magnetic response, and this is the gravity response. This is the big, massive, 1 kilometer deep half bowl of olivine peroxenite. Big mag response, big gravity response. This is 1.7 kilometers of olivine peroxenite. And so I argue, I say, well, no, it doesn't exist, right? It's not, it doesn't have, that response, you can't have 1.7 kilometers of olivine peroxenite where 1 kilometer looks like this and 1.7 kilometers looks like that. Anyways, that's providing a lot of debate time. Yeah, so this is just the first example of where we're drilling deep on concept and on the seismic data. The second example here in sediment-hosted copper, we're here in the Zambian. We work on the Zambian side of the Central African copper belt. So just to understand why we're doing exploration the way we do, just a few slides on understanding in a very simple way that a geophysicist like myself can talk about and explain the nature of the geological setting. So a very generic kind of basin diagram. We've got these hematitic sandstones called red beds here at the base. There'll be some initial conglomerates and stuff, but this has mostly been thought of as the source for the copper. So this basin sits here as a closed basin for a long time, and the brines become quite saline, and they flow around and they scavenge the copper from down here, maybe from the basement. In the end, it doesn't really matter. We've come to the conclusion in the copper belt that there's so much source copper around that you don't have to worry about where it came from. You just have to worry about where it ends up. And so on top, you've got, at some point, shale horizons, sandstones and shales, and carbonate that may act as a cap. But really what happens is the copper-rich fluids come up from below, and they find the basically first reducing horizon. So these are oxidized. They hit the reductant, a shale, often a black shale, could be a siltstone or something, and they dump out the copper. So the very simple exploration model is you look for the first reducing horizon above the basement. And it helps if the basement is close to surface, so you don't have to drill 5 kilometers. So really simply, we look for basement domes, because this can be very laterally extensive, these shale beds, obviously. And so where are they going to be located along here? Look for basement domes to help both focus fluid flow and bring everything within economic reach to the surface, and structure to help direct the fluids. So basement domes, structure, and reducing horizons, the three ingredients. And just a few rock pictures. So basically, these are the kind of shales where you get the copper mineralization in. They can be quite dark shales, or they can be more kind of interbedded shale, sandstone, dirty sandstones. And here's the example where I'll show about the drilling. So this is an EM channel image, but it's simply showing that. So these are the 2 existing pits, and this is a third development now, where the EM is imaging a phyllite, which follows the domal geometry of everything, of all the other stratigraphy. So where the phyllite is coming closer to surface, you're getting these domes. This has actually been mined out, so it's not quite fair. I do believe this will probably be a big red blob. And this is from drilling, just the depth of one particular stratigraphic horizon, showing the higher domes and even little domes upon domes that tend to concentrate the mineralization. Here, just a shot through the main pit. All the drilling is obviously where all the mineralization is. So these apices and the domes are where we hunt for the copper. Copper is hosted mostly in this we call middle mixed clastics, and it's interbedded with marble. So this is this is quite high up in the stratigraphy of the copper belt, not the classic copper belt. And so we started drilling a hole, not necessarily on this section, but a deep hole, to see if we could find the basement. And actually, it was a bit serendipitous. One of the drilling companies that do drilling for us wanted to test a new rig, and so they offered to drill 1,000 meters for free. And we said, great, I don't think they expected it to all be in one hole. But they drilled the first 1,000 meter, and we fronted up the cash to keep going. And we're intent on reaching the basement because what we actually want to kind of prove to ourselves is that there are no other reducing horizons below this mine, Kansanshi. If there were, we'd be in danger of having a lot of our copper gobbled up by the lowermost shale, and even though this is a substantial deposit, we'd be shortchanged. So the drill is still turning as we speak at 2.3 kilometers and no basement. So no mineralization for 2.3 kilometers, and we're still going. A bit crazy, but maybe we're in it going for broke. But we're happy that we haven't hit any mineralization, and we're happy that we haven't hit any reducing horizons. So this is a kind of a very good example of the kind of geological hole, which is not done for any sort of immediate economic impact. So yeah, drilling result nil. So that's the irony, that the hole we drilled in Finland, we really would have loved to see mineralization, or at least evidence of process. And the hole we drilled here, we were very happy to see nothing. So this basement domes concept, there's we've been doing a lot of AMT in the Copper Belt with the idea of trying to map basement domes to help us focus our exploration. So again, we're doing the MT survey. We don't want to actually find sulfides with the MT. We want to map basement topography. So a bit of a control line where the basement comes to surface. This is down here on the Zambia-Congolese border. So this is basement outcropping, and then we've got various sedimentary horizons, a lot of shales providing the conductivity signal. So okay, we can map basement versus sediment. So we extended this a bit more, and we have drill control here through the mine, and we're pretty happy because we have models, of the geology around the mine where we, even if we don't see, we invoke basement topography. So anyways, it looks like it's doing a reasonable job. We're not concerned about details, although this looks like interesting different shale horizons being imaged here, but we're interested in this kind of thing. So okay, that looks okay. Let's send the guys out into the bush to go as far as they can for about 40 kilometers into the rather difficult to get through Congolese pedicle, using any tracks and stuff and they could find. So this is the image I just showed you before, was this little piece, and now we've just gone all the way out here looking for these kind of things, which could be basement domes. And then we would go there and we would do our soil sampling and stuff. Instead of soil sampling 40 kilometers, we could restrict ourselves to this, for example, or this for any follow-up exploration work. Unfortunately, a whole other story. We're no longer in the Congo, not by our own kind of. We didn't volunteer to leave, so those remain untested. So the conclusions is, for first quantum at least, deep drilling is about geology and not metal for a lot of the time. Improving stratigraphic and structural understanding with the goal of helping us find the shallow mineralization we want to. Our CEO has reminded us on numerous occasions he's not interested in underground mining. So actually, there's upward management with this. It's the job of our exploration director. Why are you drilling 2.5 kilometers? We don't want to see anything below 500 meters. And as Ken alluded to in his talk, seeing deep is a fight against physics. But so we've been using the MT as a kind of poor man's seismic. It certainly doesn't have the resolution. Seismic is, in my mind, is going to be a very real part of future exploration for minerals. You have to balance the dollars. That's the barrier is the entry barrier is the cost, but the outcome can be significant. Ken also mentioned this, geologically constrained inversions of various data sets. So, for example, if you have a gravity inversion, an anomaly sitting somewhere, but you actually know that anomaly is, you're pretty sure it's not in the top 500 meters, and you can force that issue, you're in a sense, you're improving your depth resolution with this geological information, because you're forcing the inversion to put this anomaly in a geologically reasonable place. And obviously, yeah, explorability, something we talk about a lot, depends on the deposit style. And again, people have mentioned this already, but deep drilling at 1 kilometer centers is something that Dan also mentioned in his talk, Dan Wood. And that makes sense for hydrothermal systems where you have these huge alteration footprints and where you're going to be doing everything down these holes other than, you know, sampling for copper or sampling for gold, but all sorts of geochemical suites and whole rock geochemistry, and being smart about the alteration footprint. That's one of the big things that will help us in deep exploration and undercover. In contrast, something like nickel sulfide, which has a very small to nil kind of exploration halo, it's certainly not economic to go drilling 1 kilometer holes and you'll just kind of step over it and keep on going and never knew you were near it. So that's it for this talk. I'll just stop the talk with those 2 questions up on there so that people can be reminded about what might be interesting to discuss. What is undercover, and what was undercover 20 years ago, is that still undercover today? And do we actually need to look deep? Thanks.
Thanks, Chris. Field any questions? Peter Gunn.
Thanks, Ken. Just a comment. You seem to be exploring in rifts in the Congo area, and you're trying to identify basement highs that you've got these domes over. If you're in a rift, you can actually get if inversion has occurred, you get the whole rift squeezed up, and you get these anticlines and so forth, which aren't associated with any basement feature. To check that there are over basement features, you'd have to see whether the isobacks change and stuff like that. But that's just a comment. Thank you.
Yeah, well, it's not a rift. It's maybe an incipient or a failed rift. It's a basin. It's never rifted. Never actually become a rift. So probably in this basin, there's been a considerable extension and just a very little bit of compression at the end. So there's doming and stuff in the stratigraphy and thrusting and stuff that exists, but. Well, we're following the concept of looking for the basement domes. But as I said, that's partly because, I'm sure there are some great copper deposits in reducing horizons at 4 kilometers depth, but, who's going to go for it?
Mark Duffett, now Mineral Resources Tasmania, but previously at Codes and doing regional geophysics in this area, and we did hang a lot of the interpretation on the gravity response of the basement domes. I seem to remember there's one outcropping not far from Kansanshi. So what responses are you seeing from the outcropping basement domes, and are they apparently different?
No, that's really interesting, and I'd like to talk to you more about it, because the basement domes, okay, and the gravity is very poor across the copper belt, and you guys in the Amira project collected what you could. But the basement domes, the basement is orthogneiss usually, but the outcropping, like at Lumwana, for instance, they've got the granite core, right? And so the basement domes are all gravity lows, and the basin fill is the gravity high. And so my personal belief is, even though you can't see it, I think all of these basement domes are cored by granites. And you actually get a density contrast between these domes and the basin fill. The basin fill is dense. I mean, there are a lot of carbonate layers, and hematitic sandstone. So that density contrast approaches the density contrast you find in a granite greenstone terrain. So that's quite considerable. So I think that all of Zambia should be flowing by airborne gravity. That'd be an amazing step change in the understanding.
Just a couple of things. I think first of all, I congratulate you in Kivitsa. I think you found the first gravity remnants anomaly. That's the only way you can explain that drill hole. And I'm sure Professor Yaguali will rush back and get 10 students on it with money from First Quantum.
Or we drilled down an ultramagnetic pipe and yeah, no.
But a couple of other comments. We were going to have Dan Wood here. Unfortunately, he had to shoot off on some well-deserved leave. And then we were going to have Dan in the can, and then, well, no Dan in the can today, but his talk is available. The reason being, his ASEG Distinguished Lecture from 2012 is available off the ASEG website, and certainly as a great document about the future of bulk mining. I would recommend spending the $25 or whatever to get that DVD. But one of the things he mentioned at dinner, he says people are designing pits now to go to 1.5. I mean, if the Olympic Dam thing ever gets off the, out of the blocks, that's the sort of depth they're going to be going. So your CEO or chairman, 500 meters is the old limit. You talked about old standards. 500 meters is the old standard. And Dan, of course, said, thinking about being in the bottom of a pit that's 1.5 kilometers down is not a pleasant feeling. That is a way, way, way down there in the earth. The other thing is that, you mentioned the nickel in the deep holes. Inco and Falconbridge some years ago developed a fairly sly strategy in the Sudbury Basin, and Inco started logging these legacy holes dating back from even before World War I in the basin. It's a very stable environment geotechnically, and they had something like 30,000 holes that were capped, and they started a systematic program of going in and doing downhole EM. And they actually have strategies built around now of totally drilling holes as platforms for downhole EM. And we're talking holes here in some cases deeper than 2 kilometers. And so it's not something that really has jumped out and is being applied everywhere around the world, because obviously we don't want to drill those holes. But you mentioned deep nickel in the holes. I mean, that's the way of increasing your search radius around some of those. If you know the geological environment is permissive, there is technology out there that people are using as we speak. So, all right. Well, if no more questions for Chris, we're a little bit ahead on time here, and we'll get into our last presentation. And we're going to shift gears here a little bit with this. Yaguali is going to talk about a program that.
Deep exploration. I just want to point out, when we bought this company, Inmet, we inherited a mine in Puusaari. So we actually have 2 underground mines incidentally to the purchase. But this one in Finland, I just thought it was interesting, is home of the world's deepest sauna. So you talked about standing in a pit at 1.5 kilometers. How about having a sauna 1.5 kilometers below the earth in an underground mine?
I would have a very large vodka with me with that.